On November 20th, 2025, the South Texas night was shattered by the violent destruction of Super Heavy Booster 18, the first of its kind for Starship V3. The booster wasn't even being launched, just a routine pressure test at the Massey's site. Suddenly, an explosion ripped through the lower section, leaving only twisted metal behind. This was a major blow for SpaceX. Booster 18 was the pathfinder for Starship V3, a vehicle meant to carry heavier payloads and, eventually, humans to Mars. The loss, before engines were even installed, was a stark reminder of the risks in pushing rocket technology forward. Early investigation pointed to a catastrophic failure of a composite overwrapped pressure vessel, or COPV, a high-pressure tank used for helium. When a COPV bursts, it releases explosive energy, and that's exactly what happened here. Thankfully, the test was remote and the booster wasn't fueled, preventing a much larger disaster. Still, the vehicle was unsalvageable, and the Starship V3 schedule was thrown into chaos. SpaceX now faced a critical challenge: find the root cause, fix it, and get back on track, fast. The world was watching to see if SpaceX's rapid iteration philosophy could withstand such a dramatic setback. In traditional aerospace, a failure like Booster 18's would mean months of delays. Not at SpaceX. Just days after the explosion, hardware for Booster 19 was already being stacked in the Mega Bay. This wasn't for show, it was a clear message: learn, adapt, and move forward. SpaceX's unique approach, building, testing, failing, and fixing in parallel, lets them recover at breakneck speed. While engineers dissected the Booster 18 wreckage, the Starbase production line never stopped. Stacking for Booster 19, set for Starship's 12th integrated flight, was scheduled for December 2025. Meanwhile, design changes were already underway, ensuring Booster 19 would be stronger and safer. SpaceX's aggressive recovery plan was public and bold: resume flight operations in early 2026. For SpaceX, failure isn't a reason to slow down, it's a reason to accelerate. The company's resilience and speed are redefining what's possible in rocket development. The loss of Booster 18 became fuel for innovation, not a roadblock. The world watched as SpaceX turned disaster into momentum. The Booster 18 failure zeroed in on a familiar industry problem: the volatility of COPVs. These lightweight, high-pressure tanks are engineering marvels, but also notorious for causing catastrophic failures. SpaceX's investigation confirmed a COPV burst as the root cause, focusing all efforts on making them safer. The solution: a reinforced COPV design, with improved manufacturing, mounting, and protection from vibration and heat. This wasn't just a patch, it was a comprehensive overhaul of the pressurization system. Engineers also looked at containing future failures, adding shielding and relocating critical components to minimize damage. The goal: a booster that could survive certain internal failures, not just launches. This rapid, iterative learning is SpaceX's hallmark. Each failure feeds directly into a stronger next version. By the time Booster 19 was stacked, it wasn't just a replacement, it was an evolution, built on hard-won lessons. SpaceX's approach turned setbacks into stepping stones toward a safer, more reliable Starship. While engineers tackled the COPV issue, SpaceX's construction teams were transforming launch infrastructure in Texas and Florida. At Starbase, a second orbital pad neared completion with major upgrades to support a higher launch cadence. The original pad was being rebuilt from the ground up, optimized for future Starship versions. This relentless infrastructure investment is key to SpaceX's vision, not just building rockets, but the factories and pads to launch them at scale. On Florida's Space Coast, SpaceX expanded at Historic Launch Complex 39A and took over SLC 37. Starship's sheer size brings new safety challenges. Launches require expanded safety zones, impacting nearby competitors like ULA and Blue Origin. During Starship launches, operations at adjacent pads may be forced to pause, creating logistical and competitive friction. Starship's disruptive presence is reshaping the industry, forcing others to adapt to SpaceX's scale and ambition. The landscape of American spaceflight is being rebuilt, literally and figuratively, around Starship. While SpaceX pushed forward, Boeing's Starliner program faced a crisis. After years of delays and a critical in-flight failure in 2024, NASA and Boeing announced a major restructuring. The failed crewed test flight forced astronauts to return on a SpaceX Crew Dragon, a public blow to Starliner's reliability. NASA cut Starliner's guaranteed missions and downgraded its next flight to an uncrewed cargo demo. Boeing must now prove its hardware can fly safely without a crew before regaining NASA's trust. The future of Starliner hangs on fixing its propulsion system and executing a flawless uncrewed flight, not expected before 2026. Starliner, once meant to provide redundancy, has become a cautionary tale in spacecraft development. The fates of Starship and Starliner are rippling through NASA's Artemis Moon program. Artemis depends on commercial partners, and any Starship delay adds pressure to the 2027 lunar landing goal. To hedge its bets, NASA opened the Artemis 3 lander contract, inviting both SpaceX and Blue Origin to compete. SpaceX responded with a streamlined mission plan, likely reducing complexity to meet the tight schedule. NASA's new approach aims to foster competition and reduce risk, learning from the Commercial Crew program's hard lessons. The agency's lunar ambitions now hinge on the successes and failures of its partners. Starship's rapid recovery offers hope, while Starliner's struggles are a constant warning. The road to Artemis is being paved in real time, shaped by engineering breakthroughs and setbacks alike. The end of 2025 revealed a new era in American spaceflight, a tale of two approaches. SpaceX, undeterred by failure, accelerated after Booster 18's loss, stacking Booster 19 within days. Their culture of rapid iteration and public learning is redefining the industry. In contrast, Boeing's Starliner, slowed by systemic issues, highlights the challenges facing traditional aerospace. The competition is now about hardware, flight rate, and resilience, not just contracts. SpaceX's infrastructure upgrades signal a long-term intent to dominate the launch market. As NASA's Artemis ambitions depend on these commercial giants, the stakes have never been higher. The rise of Booster 19 embodies optimism. Technical hurdles can be overcome with determination and ingenuity. The journey to the Moon and Mars will be marked by both failures and triumphs, but the momentum of this new era seems unstoppable.